let's get started. Thank you all for attending. I'm hoping you enjoy your day. It's a nice afternoon. And thank you for attending this session, Net DevOps on Validation and Automation with Cisco PyTS and Genie. My name is Simming. I'll be your presenter today, and I am a technical leader in Cisco engineering, specializing in test tool development. So today we will journey into Net DevOps and how you can evolve your current way of doing things, hopefully from a, or not hopefully, but from a more primitive, manually based perspective into the future, where everything can be automated, where you can gain insight of how your network is doing without really having to rely on too much human expertise. Right? And we'll go through that with a lot of examples, use cases, going with something you're familiar with. Now, when you think of network testing or network validation, there's a few things you can actually think about, right? Testing and validation tends to go hand in hand. The first thing you tend to do whenever you have a network is to make sure that your configuration is pushed down correctly. Whether you're using a tool such as NSO, Ansible even, using Cisco DNA, or using ACI, you have a configuration management tool that's pushing configuration to your topology, right? Once that's applied, the next thing you want to think about is how is your network operation status doing? What are your neighbors? What's your routes? Whether your interfaces are up? What's your counters, right? How many users you got? What's your CPU usage? What's your memory usage, and so on. There's a lot of things that configuration management doesn't give you, or the side effect of configuration is not often looked into. And then lastly, you have device health. So whether your interface is up, that's both a status and also an indication of whether things are going right or wrong, right? Depending on your network topology, the device health is a combination of various operational status that's computed all together. So oftentimes we ask the question to our audience, and we can have a bit of interaction here, how do you validate your network today? Right, does anyone want to try and answer this question? No, maybe give it a try. Yeah, go ahead. Sorry?
Infrastructure monitoring.
Infrastructure bunkering, okay, that's a step, but you're way ahead of a lot of people. We've heard of all sorts of answers ranging from, I got a guy in my lab, or I have a network engineer who's got expertise, I got CLI commands, I do various things. But at the end of the day, if I say, can you repeat it time and time and time again? And they say, not exactly. All right, not exactly, and that's not what you want to hear. Let's go through a typical use case. Typical network management day, you're telling it to your device, or your SSH into your device. Let's say you're a CLI user, you're a network engineer, you're great with CLIs. You rely on your expertise. You do some show command, you figure out what your interface is doing, right? You look at a lot of text. You look at your BGP verbs, you look at all your routes, is it good? You look at your IP interface, look at the verb. Right? You're looking at all these things and hopefully your network is behaving normal. So then you say, okay, my systems go. This is the hopefully 100% of the time. But as always, things go wrong. Disaster strikes. Now, obviously, somebody tripping over a cable is less likely to happen, but imagine this is a typical situation of someone chewing through a cable, you had a network issue, disaster occurs. What happens then? How do you troubleshoot it? Right? Obviously, configuration didn't change, but the operational status changed. How do you figure it out? And as human, we tend to always rely on our instincts, rely on our expertise as network engineers, and we go and use some of the most primitive tools. I'm sure people have done this before. So this is a text diff of show interface before and after something occurring. And obviously, because it's a text diff, anything that's different is going to highlight for you. So I would call there's a lot of noise involved in this. So we're looking at counter changes, we're looking at state changes, and finally, maybe you could come across the fact that, oh, the link is not connected, right? Because someone tripped over a cable. This is a trivial situation, but you can apply the same technique, or a lot of people apply the same technique over and over again in day-to-day operations, because this is what they're familiar with. Right? And obviously, you can get very good at this to pinpoint the fact that this is down and ignore the rest of it. But as human, we're prone to making mistakes. Depending on whether you had a good night of sleep before, whether you had a lot of coffee this morning or a lot of tea, if you prefer tea, right? You can make mistakes. You can glance over this and forget the fact that the link was not down. Now, what if it was, say, a lot of CRC errors on an interface? Would you have caught it because it would have been buried in the middle of a lot of text? You wouldn't. And that's where automation come in. So the proposal is, what if you had some sort of tool that you still are familiar with? Let's say it looks like CLI, but you can run it, capture the state of your interfaces. Let's stick with interface concept for now, and do an automated diff of before and after, ignoring all the noise, and then only focusing on the things that matter. That's where we come in, right? A little bit, so that's our situation analysis. It's a very simple case, but this is where we come in with our expertise. So I'm part of Core Software Group, Test Tools Development. As part of Cisco product development, there's more than just the product itself. You're using the end product, but in order for that product to be shipped out the door, there's a lot of testing that needs to happen. All of our testing is automated. All of that testing today is run on an infrastructure called PyTest and Genie, which is developed by our team. We started many years ago based on our expertise of test automation, building this infrastructure, and now it's running in CI/CD across multiple platforms. Lots of products ranging from routers, switches, data center stuff, firewall, you name it, we're probably testing it. There's over 3,000 developers inside Cisco that's using this product today, this test infrastructure, this ecosystem. There is over 5 million lines of test code in Python and libraries that drives our boxes to do test automation, and as well over 2 million test runs on a monthly basis to make sure that the product you're getting is, well, hopefully bug-free. Now, why does this matter to you? Because we've come to realize a couple of years ago that we have this amazing test infrastructure, these device driving libraries, these automation libraries that can be useful in your hands, right? They're a byproduct of software development. They are software themselves, they're quality code, and they're used to do testing, but it can also be used to drive your devices. There's a few layers to any sort of software, and we started many years ago with the foundation. Many of you probably heard it already, PyATS, PyATS, PyATS. You probably saw it on social media. NetDevOps, they talk about PyATS. So PyATS was the core test infrastructure that allows us to define a topology, connect to the devices, issue commands, get responses back, capture it, write test cases around it. But obviously that's not very interesting to you because, you know, anyone can connect to a device. There are plenty of libraries. What about programmatically accessing BGP information? That's where the next layer comes in, Genie Library Framework. So after we have this foundation of interacting with your devices, we started building our library layer. We look at netconf, which is great. Yang models are great, but they're a computer interface. They're not human friendly. Programmers or network engineers who wants to become programmers wants to have a Pythonic access point. That's where the Genie library is. It gives you a basis for how to define libraries, how to define models that represents your devices, your features, your interfaces. Then on top of that, we build those actual libraries. So when we say we have a library in BGP, it means that we have used the Genie library framework to develop BGP models that's suitable for XE devices, for NX devices, for even Juniper devices, third-party devices, right? So these are the three layers that we've developed. Then on top of that, once in your hands, you can use it with any infrastructure or tools that you're familiar with, right? Remember, whenever you build software, it's like the tip of the iceberg. You're using it from top. You're interested in the user aspect of it, but we have to build software from the ground up. So whether you're interested in Ansible, you want to do some robot framework, you just want to run some stuff in Jenkins or in command line, in the first use case that we have, right? That's where you are. You want to be integrating to the part of your network. And the best part about this is you don't have to pay $1 for it. It's available on DevNet. Because it's a byproduct of engineering, we've already created it. We've shifted to DevNet, and today you can go to Docker Hub and download it. The image is ready for you. If you're familiar with Docker containers, boot it up, you can do it already. The source code is open source. The libraries are open source. You can go to GitHub, Cisco Test Automation, look at all the libraries we've developed so far, millions of lines of source code that says here is how we model BGP or OSPF or segment routing. This is our main product page, so if you go to developer.cisco.com/PyATS, you can find out all the use cases, cookbooks, everything that we talked about here will be available on this website. All right, so this is where you can get it, and let me remind you again, you're not paying $1 for this because it's a side effect, it's a byproduct of engineering, and we make it available so that you can do your DevOps without having to write your own libraries, right? It's on DevNet, it's on Python package index, and you can just pip install it in your environment. All right, next question that we get a lot before we get into the use cases is what platforms do you support? What features do you support? Many. We did not code this infrastructure because we are part of core software group, because we had to test XE devices or Nexus devices. We needed a test infrastructure and a library infrastructure to develop libraries that model various devices and various features. So the core itself is agnostic. As an example, we support plenty of devices, but we can also support third-party devices, or I shouldn't say this, but competitor platforms. Everything is agnostic. Everything comes in via a plugin, via library dynamic loading. It's all built into the infrastructure. Now, let's talk about the actual evolution. So obviously, when it comes to evolution, let's not start here because we've been at this for a couple of years. Let's start here. Network DevOps. The first step of any network engineering, after being a CCIE for many years, we've had people come out to us and say, look, I love automation, I know it's the future, I want to automate my DevOps, where do I start? Right, because there are plenty of courses today, even in DevNet for say REST APIs, Python development, how to use an SDK, but at the end of the day, you learn the language, but what can you do with the language is the question, right? How do you do it is the question. Where do you start? Or jumping from the fact that you're a CCIE engineer to a software developer, it's a long jump, it's a long shot. How do you get there? So the first thing you can do is the first case that we showed you. Why not start at the command line, right? As part of PyATS and Genie, we have command line tools. So Genie command line gives you the power of the entire model library, being able to profile your network, being able to profile various protocols, save it as a file, do whatever changes that you're used to, whether you're using a tool to do this, or whether you're using command line to change your configuration, push the configuration down, and then take another snapshot of your operational status, compare it. Get the programmatic output, right? Here is an example. Learn it. So in this case, profile BGP, profile interface, profile this entire platform. Issue all the commands necessary to learn everything there is about this device, save it. Do whatever changes that you have to do, and then do it again, but do a compare. The comparison is going to tell you exactly what changed in your network. So in this case, it looks like someone shut down my BGP neighbor. Obviously, this is a configuration change, but the configuration change yields an operational status change, and this is learned from operational status. Now the question you might have is, how does this dark magic happen? Because you can't just issue commands and assume that something has happened in the back end. What we do is our team's engineers and feature test engineers and CCIE engineers study netconf model, study the protocol across different platforms, and they come out with a top level Python model that says, when I talk about profiling BGP on various platforms, here is all the commands I have to issue. Every single one of these commands is then parsed into a Python data structure, and then we convert that Python data structure into, I'm afraid it's a little hard to see, but hopefully you can see this. It's a mega-sized Python data structure, let's say a dictionary. It's a little bit more than a dictionary, but let's say a dictionary that represents the entire operational status of your BGP on this platform. And with this, if I had the before and I had the after, doesn't matter how the configuration changed, doesn't matter what was the side effect of some sort of disastrous event, let's say a link was lost, right, or a line card was lost, if I do the comparison, I can get a programmatic output of exactly what changed. Now, obviously, the infrastructure and the library is not going to tell you whether it's good or bad because you might have intended effects. So this is where you build on top. Our library allows you to interact with those features without having to write too much code on interpreting device output, where you can focus on writing the business logic on top. Anyone see the value add in that? Right, hopefully you see some value add in this, right? And this is precisely how we test Cisco products today inside engineering. We model the features, we drive it with different ways of doing things, and we look at the output and say, is that expected or not, right? We can learn everything there is about this topology, compare the profile, and then say whether this output is expected or not, right? That's one way of doing testing, but you can harness the power of this in your validation. That's step number one. Command line, without any Python knowledge, without being a programmer, as a network engineer, anyone can do this. All you need to do is understand how our model works, and there's a PDF file for that. That's not very difficult, right? Now, next step, let's evolve, right? Obviously, as a network engineer, you're getting into DevOps, you want to evolve. You want to start writing code. Pushing you straight from command line into coding in Python might be a bit too much, might be very difficult. So let's evolve into the next step, because even if you are the perfect Python coder, you cannot show your test code to upper management. You cannot show your test code to network architect because they won't understand what it is. You need a medium in the middle, and that's where Robot Framework comes in. So Robot Framework is a Python package that allows you to write test cases or code using English keywords. It's almost as if you're writing an English natural language. Now, if you've never seen Robot Framework before, here's an actual example, and I bet every single one of you can understand what this test case is trying to do, right? It says, use this particular test bed using some test bed that was passed in, connect to these devices, these are environment variables, by the way, and profile the system for interface on devices. Now, this is where I call tip of the iceberg, the top level, the integration portion, because this drives our libraries in the back end. You don't have to understand Python, even though it is developed on top of Python. So this translates into API calls that gives you results. Now, you can still launch it at the command line or using any sort of CI/CD tool, say Jenkins or whatever you're familiar with, GitLab, however you're familiar with, and get a result output. Everything is passed, but you can give this to upper management because the log will tell you that, yes, the test passed, and within the log it's going to tell you exactly what are the commands that was issued. So in case they want to drill down into exactly what was passing and failing, what are the case analysis, it's there, right? So you have now a medium between network engineer and management. You have a medium between being a network engineer, being a DevOps engineer, to actual programming, right? You have an interface in the middle where most people can understand. You can do more with that. So let's go back to our previous use case where we did a snapshot of my interface status, and then I tripped over a wire, right? That happens in our lab. I'm not sure about your lab, but that happens a lot in our lab. And I want to do a comparison. So in the same case, once I profile the interface again, I have a keyword for comparison. Compare this snapshot versus the current one or the previous one. That comparison, once I run it, so I run it, I pass in the testbed file, a YAML representation of what devices I have, pass in the device I want to run it on, the previous snapshot file that was generated from the last run, I run it, and I get this output. Now in this very simple scenario, we can read that on Gigabit Ethernet 3, on IPv4, our IP changed from 2 to 3. Again, a very simple scenario. It's not a configuration change. This is all based on show commands. This is all based on operational status. It's not limited to show command. The infrastructure runs over netconf, runs over restconf, and you can run it over CLI because, I'm using this example in CLI because most network engineers are more familiar with CLI. right? But this is a suite you can run. It's no longer a command line. And integrating this into some sort of pipeline, or even as a cron job, now you have a snapshot of your network's operational status on a daily basis, on an hourly basis, or on a 10-minute by 10-minute basis, right? Now you can have a historical trend of how your network was behaving, what was the operational status of your network over time. And when things go wrong, you can do a comparison and say, look, that changed? I don't know what happened, but that changed. And with that operational status, you can figure out exactly why things are happening, right? Another use case that one of our sales engineers came up with, Kevin Corbin, he's a great guy that we work with, is he said, people always ignore one critical thing. You have hundreds of interfaces, and most of the case, your interface CRC numbers are 0. You're not expecting line issues, right? Physical hardware issues. But when a case arrives, or when an issue goes on, you get a case, it becomes critical, then you start figuring out why is my traffic losing, why am I losing traffic, why am I losing neighbors? Then you start doing show commands, and then you start figuring out, oh, there are CRC errors. So either I got a hardware issue or I got a line issue, right? Note in this situation, you're being passive. You're being passive because the problem already happened, you got a case, and you had to go back and figure out why that case happened. You want to be preemptive. You want to be proactive. You want to continuously run a script like this that continuously takes snapshots. And one of his scripts, very trivial example that he came up with 10 minutes, is he takes a snapshot of all the CRC counts every night. Whenever that number increases by 1, above 0, it fails the test case and tells you that interface is failing. Before you even get a case, before a customer comes and say, I got an issue here, I got a network reachability issue, you already know. You already know that you're having CRC issues. Chances are you are being proactive, right? So that's the power of automation. That's the power of what automation can do for you. What about service resiliency, right? Now, obviously, you don't want to do a switchover in your production network. Most people are not comfortable with that concept. What if your network is really resilient, right? Over at Netflix, they have this concept of chaos monkey. So they have a program that goes around and breaks stuff, and they expect the system to automatically recover. If you had a perfectly laid out, well-maintained, well-designed infrastructure, you should be able to afford things like this. Trigger a switchover and see what happens. If your network failed, someone's not doing it right. You can do a reload, view your redundancy status, right? These are various keywords that you can use today that comes with the infrastructure, and it all depends on how you want to do it. Whether you call it testing, whether you call it verification, whether you call it validation, it's all a combination of how you want to use this library, because the library allows you to drive the box. Now, let's evolve a bit more. I hate to say it, but we're not really going to the dark side of things. We're not becoming a Darth Vader. But let's assume that a couple months or a couple years or however long down the road you become a Python developer, right? You want to write more code. You're familiar with the infrastructure, you're familiar with the code, you know, you're wielding a lightsaber. I really should have changed this to Luke Skywalker, but you get the idea. Out of the box, Pythias and Genie comes with a pool of test cases. They classify into 2 parts: triggers, which are actions that trigger changes on the box. So in the previous case, you already saw do a reload, right? Or trigger an interface shut, bring it back, right? Or delete a neighbor. That's a trigger. It triggers a change. And then you have verifications, which is the execution of various commands, and then compare to see whether the changes are intentional or not. With these 2, which are a pool of test cases, the combination of them gives you the power to do reusable, scalable, and data-driven automation. Whether you think of that automation as testing or validation is up to you, because it all depends on your point of view, right? But using a YAML data file, you specify that I want to clear BGP. The max runtime for this test case is 30 seconds. Sorry, max runtime is 30 seconds for 10 intervals. I want to run it on this particular device. And then after which, I want to run this parser and show me BGP all summary. The combination of these two drives the harness infrastructure to automatically generate test cases that does the verification first to take a snapshot, perform the trigger, and then take another snapshot and do a comparison. Now you have a way to build network testing, network validation, network automation, right? This is based on PyATS output using Genie libraries, right? One rides on top of the other. The two goes hand in hand. Obviously, we're not limited to just BGP, so the next question people have is, what protocols do you work with? What platforms do you work with? I already gave you examples, ESR1 case, Cat9 case, right? Anything that you're using within your network, we can adapt. If there's a library that's missing, remember, everything is pluggable. We can inject it, we can plug it, we can extend the libraries, right? We're platform agnostic, OS agnostic, vendor agnostic, management protocol agnostic, and even release agnostic. It all comes down to the libraries. And we have a lot of libraries. Go to GitHub and check it out. Now, obviously, we went through some fairly simple use cases, and the next question people have is, where do I go from there, right? There's a great cookbook. So if you go to the DevNet portal, developer.cisco.com/pyats, on the doc side, there's a cookbook, which our friend JB here wrote over many nights. So JB is the man behind Genie. He's the genius behind Genie. The cookbook basically walks you through what's an operational model, so operational objects, what's a configuration model, how do you perform configuration, and what are various use cases. I want to do a comparison. How do you do it? I want to take a snapshot and then build logic on top. How do you do it? This is where it all comes together. We call it a cookbook because, well, you're not cooking, but you're really cooking your network. You're cooking up your network. How do you get started? Very simple. This morning I got an email from one of our customers that says, this is lovely. It's running on my VM, and the spec of that VM is pretty much just a potato, right? I think he said potato. It doesn't require a lot of power. If you have a VM with 1 gig of RAM, 1 vCPU, chances are you'll be able to run Genie and PyATS. It won't be very fast. It won't be able to learn 2,000 devices at the same time. You need to scale Python. But we don't use a lot of memory or power. Everything is Python based. It's available on Python package index. At the bare minimum, if you have a MacBook or Windows subsystem for Linux, or any Linux environment on your laptop or in a VM in your lab, all you need is Python 3, 3.4, 3.5, 3.6, not yet 3.7. 3.7 is unfortunately not backwards compatible with 3.6 in many ways. We're fixing that. In a couple months, we'll have a release for 3.7, but that's all you need. And then you create a virtual environment, pip install, and there you go. Right? If you're familiar with that, that's all you need. If you're not, and you just want a Docker container, go, Docker pull, Cisco Test Automation /PyATS, everything is there for you to use. Plenty of ways to use it. Lots of resources around. You can go to DevNet. We've been working with DevNet Sandbox on creating various training sessions. We've been working on various self-paced tutorials. There's obviously a lot of stuff to learn. There's obviously a lot of infrastructure because we built it layer by layer. There's a lot of protocol. It's a design language. It's a design architecture, right? So there's lots of things to go through. And one thing for sure is we don't lack documentation. PyATS alone comes with 800 pages of documentation. You may not want to go through all of that. That's why there's a cookbook for use cases, right? Remember, think of PyATS as a toolbox. The toolbox allows you to do things, but it's very flexible. Genie is the product that you want to use to interact your devices with, right? Lastly, there are related sessions. So thankfully, I am actually the first session to introduce you to the concept. If you want a bit more hands-on, there is the workshop, $25.95, where Jean-Bernard or JB there will be training you, and you will have hands-on experience of how to get things going. Right, so there's a session tomorrow and a session on Thursday. And as well, a lot of people are just interested in parsers. So being able to turn command output into a data structure. Even without the rest of Genie, the triggers and the verifications, if you had the libraries to turn command output into data structures, you can build management layer on top. You can build your own logic on top. So if you're just interested in an intro with parsers, there's a session on that, specifically on building parsers. It's going to happen actually in about an hour from now. And there's also another session on Thursday. All right? That's all I had. I'll leave the remaining time for questions. Thank you for attending. I'd like to close by saying that PyTest Genie is really the bridge between you and NetDevOps. NetDevOps as a whole concept in DevNet is really being driven at the verification layer by PyTest and Genie. So keep that in mind. Right, we also have a booth over there of NetDevOps. Some of you guys passed by. If you had specific questions on how to integrate this with your network, what are other use cases, what's the requirement, how do you want to work with CX teams on this, whether you can get dedicated support, come to our booth, we can work that out. All right, go ahead. We can connect to devices via various fashion. So that's a great question. The question is, how do we connect to devices? So first of all, you can install it in your lab. It does not collect any information about your lab, does not send any telemetry information back to Cisco. It's your own development toolkit, right? At PyTest level, every method of connecting to a device comes via a connection manager managed by a connection implementation. So right now we support SSH, Telnet, RESTconf, NetConf, XML. And if you really want SNMP, we can look into how to do that. But everything we do is via some sort of implementation detail. Right, go ahead.
So, how can I keep my inventory consistent? So I need to know, right, after I instruct the PyTest to connect to my devices, I need to manage somehow
the output.
The inventory, what are my devices? So somebody is on the new device.
Okay, great question. So the second question that you had was, how do you manage the inventory of your devices? Right, so there's a couple of solutions to that, or sorry, a couple layers to that. First of all, in PyTest and Genie, you define a testbed or a topology or network using YAML file. Inside the YAML file, you define what's your topology name, what are the devices, how do you connect to the devices, and how your devices are interconnected to each other. Because it's a file, you can commit it to a Git repository, right? You have version control with that. If your topology changes, you can go back to your version control and then, add, commit, do a diff, and whatnot. The first step. Second, any artifact that you generated, for example, you profiled your network, you profiled your interfaces, and you go back and say, well, what changed? You can take those files, those snapshots, save it into your repository. Now you have a version controlled snapshot of your network, both in how it looks and how it's behaving over time. And that's what we call network as code. And on top of that, come to our booth and I'll show you another product that we have called Expresso. It's a web UI that allows you to register your topology, register all the test suites that you saw. For example, the robot framework that we saw, the test case that we saw. Let me go back a bit. Nope. This script, for example, or this script, for example. Ultimately, after you've developed it, you can have it in a Git repository, but you want to be able to run it and then view the result. So we have a web UI-based solution to manage your test beds, to manage your scripts, to manage your results, to provide analytical information. We're releasing it for the first time today at Cisco Live Barcelona, but it's not part of the session, but come to our booth and we can show you that. All right? Any other questions? Yeah, go ahead. Sorry?
How is Ansible integrated with Genie?
Great question. So the question was, how is Ansible integrated with Genie? I'm going to leave that as an open-ended question. So we work with Ansible, we work with people that use Ansible. Ansible focuses a lot on the configuration pushing side. It'll figure out what are configuration changes, configuration management. It doesn't really call Genie yet. We've been working with a couple of teams that came from Ansible in Cisco, and they're looking to build an Ansible module that allows them to call keywords like this, that allows them to invoke triggers and verifications, to profile the network, and do stateful comparison. We've been working with them on that. At the bare minimum, in Ansible, in your playbook, you can issue a command to run this. Right, so without that deep integration as part of your playbook module, you can still call this from the command line. This Python Genie has been integrated with plenty of tools. One of the latest prototype we had was in NSO being able to call Genie directly within NSO. Right, so there's various ways to integrate. The most important part is, do you have the libraries? Well, once you have that, the rest is just integration. All right, any other questions? No? Well, I thank you all for your time. I hope you enjoyed the session, and visit us in our booth.